All right, welcome back. We're going to take a look at number 4 right here. We'll continue our discussion on the antiderivative of base not e. Remember, our rule today is the antiderivative of a to the x dx is just a to the x over the natural log of a plus c1. So for number 4, we saw this one yesterday with e to the x. The easy way to do this one, we have 5 to the 2x over 1 plus 5 to the 2x. Now, I know the derivative of 5 to the 2x is going to have a 5 to the 2x into it. So I'm thinking use substitution, and I'm going to use my bottom to be my u, because remember, if I think of the bottom as a quantity, that power is just 1. I can let my u be this 1 plus 5 to the 2x. Our du would be 5 to the 2x. Be very careful with the derivative. That becomes a natural log of 5 times 2. Don't forget like that chain rule right there, dx. So we would get dx equals du over 5 to the 2x times the natural log of 5 times 2. Rewriting our integral, we get this 5 to the 2x over u. We're going to get du over, and that's the u to the 1. We'll talk about that in a second. 5 to the 2x times the natural log of 5 times 2. Notice the 5 to the 2x's cancel, and that's nice. But we have this constant. Now remember, these are a constant right there. There's no variable there. So I can just pull those out to the front. Natural log of 5 times 2 times 1 over u du. This is our rule from earlier this week. That is just our natural log of u. So my antiderivative will be 1 over, and I'm going to put my 2 in the front here, 2 natural log of 5, the natural log of u plus c1. That is it. That's our answer. Don't do anything else to it. So we get our answer, natural log of 5, just replace the u, which we said was 1 plus 5 to the 2x plus your constant of integration, and there's our answer there. Now notice I do all my work the same way every time. So go and try number 5. 5 is the same way. Pause it, and then take a look. So I'm going to make this my u again. So my u is going to be 1 plus 4 to the 2x. Our du is going to be 4 to the 2x, natural log of 4. Because remember, the derivative of 4 to the 2x, right? Or let me rewrite that. Let me be more generic. Our derivative of a to the x is a to the x, natural log of a. There's a chain rule, though I am going to multiply by the 2, dx. So dx is going to be du over 4 to the 2x, natural log of 4 times 2. And if I rewrite this, we get our 4 to the 2x over u to the 1, du over 4 to the 2x, natural log of 4 times 2. 4 to the 2x's cancel. Bring our constants to the front. And again, I'm going to put my 2 in the front there, just make it look easier so I don't confuse it and make it natural log of 8 by accident. And I'm left with 1 over u to the first. And again, that's our natural log. This is just a constant. I can just pull that all out. There's no variable there, just a constant. I can just leave it there. And we get times the natural log of u plus c1. So we get 1 over 2 natural log of 4, the natural log of u, which is 1 plus 4 to the 2x plus c1. And there's your antiderivative. Very easy to do. So easy, a caveman can do this. All right, last one, number 6. Again, this is our exponential. That's my exponential part right there. So to solve this one, I am going to let my u be my exponent. U's always the exponent on these. So we get x plus 1 squared du. I'm going to use chain rule. 2 times x plus 1 to the first dx. dx equals du over 2 times x plus 1 to the first. Now you might be thinking, why didn't I do chain rule? There is, I'm multiplying by the inside, but the derivative of the inside there is just 1, so I didn't have to do that. So when I rewrite this, we got that x plus 1, 5 to the u, du over 2 times x plus 1 to the first. And those cancel. All x's better cancel. And what I'm left with, I'm going to factor out this 1/2 here, bring it to the forefront. 5 to the u, du. Be very careful. Remember the antiderivative of a to the x right here is a to the x over natural log of our base. And our base here is 5. So we get 5 to the u. Oh, that's terrible. I made a big old mistake. Hopefully nobody caught that. There we go. I'm taking the antiderivative, so I don't need my my integral sign anymore. Divide that by the natural log of 5 plus c1. And just replace u. this becomes 5 to the x plus 1 squared, because there's my u, divided by the natural log of 5 plus c1. All right, hope you enjoyed this amazing video. Smash that like button. I'll see you next time.